All right, so let's head over to the quiz. Yay, meeting quiz for collaboration. All
19 questions. All right.
right, we got this. Okay, we got some data sets.
Sweet.
Hello, guys.
Bartholomew, how are you?
Hey,
I'm fine. I just got back from a pre-stream session for a state conference.
Oh, nice.
very nice.
Yeah.
I thought that was pretty good.
Yeah.
So we were just starting the quiz.
Okay.
T-distribution applet.
Construct a 95% confidence interval. How we interpret this is we say that we're 95% confident that the mean of the differences is between -2.06 and 4. So the question is, can we detect the difference? This can we tell?
I'm watching a video.
While the slides, 10 slides, based on our sample of 13. Well, the answer is we can't tell, even though it looks like it's tilted towards one way. But since it's possible that we can get a negative difference on average or a positive difference, and zeros within our confidence interval, we cannot tell if there's a difference. So therefore, zeros in our confidence interval, so we cannot tell if there's a mean difference in heights between fathers and sons. Okay. So then, the next example here, 27 women participated in the 9-week study, 9-week weight loss study. During the study period, participants were provided a reduced calorie diets. Their weights were recorded at the beginning of the study and 9 weeks later. The difference of the weights is defined as the post-study weights minus the pre-study weights. The researcher expected that the mean difference.
Wait, who's watching the video?
Not me.
Since you are,
Bartholomew?
you would like to construct a 95% confidence interval on the mean difference.
Oh, that is me. Oops. Sorry about that.
It's okay.
It started playing on its own. I didn't push nothing.
So are we using, like, question 3? Is it A1 or B1?
Question 3. Sorry, I'm arranging my windows. I have like 13 windows up.
Oh, that's okay. I'll wait for you.
Okay, so number 3, what is the value of the test statistic? So I've got I downloaded the 2 data sets, but I don't think we're using that yet, the 2 data files.
Oh, so this is just a question based on, okay.
Based on the above information, I don't think it has anything to do with those data files yet.
Okay.
Suppose we have a set of paired data and let D equals X after minus X before. The null hypothesis is 0. The alternative hypothesis is not 0. And the population standard deviation is not known. Jordan collects a sample of size 9 and computes line over D equals 2.2 and SD equals 3.3. Sample standard deviation of difference. What is the value of the test statistic?
Let's see.
The value of the test statistic. Okay.
I'll take these out.
X after minus X before. Oh. Never heard of this.
Get out of here. Variable 1 was
2 n equals 9. SD equals 2.3. That's the sample standard deviation.
Okay. Okay, I'm gonna run to the book real quick.
Yeah.
Test statistic.
Right, we're not using the Excel sheets yet, are we?
No, I don't think so.
Yeah, see, the next information point lists the data set you're going to be using, so we're not using that.
Let me see. Test statistic.
Number 3, what is the value of the test statistic? What is this d equals x after minus x before?
Statistic. Oh, okay. So we're going a chapter or 2 back. So the formula is, oh man, these guys know how to play with people sometimes. We're doing a t equal, you know, so it will be right below step 4 in lesson 12.
Step 4 in lesson 12.
Yeah.
Step 4 is where? I'm gonna put that there. Really delete that. Dumb. That's fair. Oh, I put it over here. That was a bad idea. Put this over here. There we go. Determine. So we're looking for the p-value.
Yeah.
Step 4.
No. That's let me go back to the book. Sorry. That's gonna miss it. So give the test statistics. So like at the bottom of that, it asks you to give. So you see where the Q plot is?
In the book.
Yeah. So if you get to step 4, just go down a little bit and you'll see give the test statistic and its value, and then it shows the formula. So right below the right above the p-value, there's an image that says for illustrative purposes only. Just right above that is that formula that they're using again, which I think in chapter 10 was T man. Let me go to my sheet quick.
Are you looking at section 4 of the book? Where are you looking?
So let's see. 1 second. I'll share my screen real quick.
Sorry, my power just got off it.
You see, ECG don't cut that thing, Abby.
Yeah, so you don't got that now.
Oh God! Every 6 p.m. the power will go out, and then it will alternate days. Those are the good days, man. Can you guys see my screen?
Yeah.
So right here, see this formula right here?
Mm-hmm.
I think in chapter 10 it was or chapter 11.
That's for question 1, right?
Question 3 or question 1 of the quiz, yeah.
Yeah, question 3. I think I got 2. What did you guys get?
So this is what I think we're trying to get out of the question that they're asking. The sample mean minus U divided by S, or student C distribution divided by the square root of N. I think that's what they're looking for in question number 3.
Yeah, so yeah, that's what I also did, and I got 2.
You got 2?
Yes.
Okay, I'll plug it in now.
Are you looking at chapter 10?
I went back to chapter 11. That's where they gave us this formula. So let me share my screen again. Right here.
Okay, there it is.
So I'm on chapter 11, and then when you go back to chapter 12, you notice that they use that formula right down there.
Yeah.
All right. So that formula is line over x minus mu. Okay. Do we know that, Dana?
I'm gonna calculate that to see if it kind of looks out of whack, then we'll have to consider something. So sample mean here is so what is D in this case? They're giving us difference, and the formula, does the formula have D on it? I forgot. Dang it. If it doesn't have D, then I don't think that would be a good.
Can you go back to the chapter 12? Let's go to
And you can share your screen too, but follow me.
okay.
That way we can just follow you. Chapter 12.
Can you guys see the data that we got over here?
Yeah.
So I think when you follow this, and it was the same data that they used for it's the same data that they use over here.
Oh, so what did it say to you S4? Where did D go? Because I know we're giving D on a quiz question. And not
Yeah.
so
Which one?
Go back to it. Okay.
This one, the 3.3.
So the 3.3 is what they use for S. What did they use for D? Or where did they put D? I guess.
Is that the 3?
The D is a 6.8. That is what when you look at here, the D is a 6.8.
Oh, so in our case now, it will be 2.2 minus 0 divided by 3.3 and the square root of 9.
Yes.
Okay. Does that make sense, Justin? I think.
Hold on, I'm looking. 6. So they put the 6.8 there on the top left. They put the 3.17 there on. So they consider that standard, and they put there. And then they put 0 on the mu.
They did, because when you're doing in chapter 12, I say when you're doing two samples, the HO mu is always 0.
Really?
Yeah, let me go to that concept and share my screen real quick. I remember reading that. Somewhere here. Okay. All right, I got it. I'll share my screen real quick so you can see where it's at. This is in chapter 12. We're back to chapter 12 over here. Let me know if you guys can see my screen.
Yeah.
So right here, the null hypothesis is that the true mean difference is 0. This is one place that I saw it. And throughout the study, you always see HOD is 0 and HOD, but I'm trying to find the main one I said specifically that I wonder if that was in chapter 13, but I know I saw it earlier. Okay, let me go to chapter 13. No,
So we're calculating the t.
yeah, we're calculating t by replacing, because they switched the formula by replacing let me go there and read a formula. When I read a formula out and kind of replace it, maybe that will make sense. And then 1 second. What's this one? So in this case, our D 2.2 here is now our X.
Okay.
And then our U is 0, because in this chapter they're introducing that when you're doing when you're using two samples, there are pretty much the same group. The mean will always be 0, because you start from 0 and then go somewhere else. And then the S in this case is the standard deviation, which they gave us 3.3, and then the N is just the same N. So the only thing that they changed here is the X bar. Well, two things: the U or the mu is now 0, and the X bar is now D. See the D with the bar on it? Yeah, that's what they're doing. So chapter 12 right here. Okay, it's coming back to me now. Where is it? Where is it? Somewhere here.
So the X is our line over D.
Yeah.
Okay, what's the mu?
The mu is 0. Because when you're operating with this, with two dependent data, your mu of the null hypothesis is 0.
All right. Divided by. So then they gave us the standard deviation, right?
Yeah, which is 3.3. And then what's the N, 9? Yeah.
Okay.
I'm gonna tweak my formula here a little bit so it can reflect that new information. That way I won't be confusing myself.
Now, what I want to know is, are we always subtracting 0 in that calculation?
If it's what do you call it? They said it well in chapter 10. 1 second. If we're using dependent variables or dependent what is it called? What is it called? Can you see my screen?
Yeah.
Okay. So in this case, where we're doing one sample test, it will be 0.
Yeah.
Okay.
I wish I can find. I literally read that thing not long ago, and now I can't find it. It's driving me nuts.
Okay, well, I got what Bartholomew was saying earlier, that it was 2.
That's what I got too when I changed that.
All right. Put it in, move on.
All right.
Number 4, probability of obtaining a test statistic greater than Jordan's test statistic is 0.403. Uses probability to determine the p-value for Jordan's hypothesis test. So So did they just give us the t there?
Yeah. Wait, should we use the t from up? The t that we just got up?
Is the 0403 the t?
No, that's the probability of. Wait a second. I think we got to pause for a second and think about back then, whenever they gave us the probability and we had to work our way backwards.
Fantastic. Hypothesis test to determine the p-value. So we need to determine the p-value.
Yes.
And that was done in the one sample test. We don't have any data though. I don't understand how we're supposed to do that without any data.
Yeah.
Start reading the book. You can start looking through the book.
Okay. To chapter 12. I'll share my screen real quick. I think that
Can you see the step 4 in okay.
So I don't know if you can see my screen.
Yep.
So right here, I think this is where our solution starts. The p-value is zero left of the t on the curve. So we're looking for this spot. Let me go back to the question. Determine the p-value. Okay, so yeah, we're looking for the area on the left of, wait, is it, this is one of those silly questions. Is it our left or the probability app left?
It would be our left.
Maybe our left, okay. This here is so small. It is not even should on this plot, please. Because what we did back then on the p-value compared to where are they getting this from? This 1.06. I think it will be from somewhere around here. I just don't know how, but when I saw this, I thought I'd share with you guys.
I don't know. Let me share my screen. Yes. Can you see this?
Yep.
I don't know how they managed to get the p-value and compare it to the level of significance. I'm just looking at.
Wait a second.
Let's see. 3.043. Do we know the degrees of freedom?
That's where I got stuck. I don't know.
We need a data set. I don't get this. It's kind of ridiculous. Let's move on. Question 5.
Okay.
So I don't know. That's the next expression. Perform a paired samples t-test. Okay, chapter 12, data A1.
Oh, we're using A1 now. Cool. Okay. A1. Right.
Okay, let's copy and paste that in.
Also. Okay, let's see. All right.
What is the test statistic? So you just, would that be the T? Is that the test statistic?
Yeah. Yeah. What confidence do they want? Not equal. Okay, that's good. Are you guys getting 0.407?
Just a second. Let me check here. Line over D. What is the line over D again? Sample difference.
That's like X bar or line over X. Wait, are you guys using the Excel sheet that they gave us? Quantitative inference procedure pair sample test?
Yes.
Okay.
I need to change A null hypothesis equals 0. Not equal to point.
The type of test will be not equal to.
Yep, and the confidence level will be 0.9.
Oh, wait a second. Did it? Oh, because it's 10. Dude, that's good. I didn't even catch that. I went right over my head. Okay. All right. When you guys are ready, just shout out your numbers and we'll compare them.
0.682. I don't really know what I'm looking for. What is the test statistic? Is that our T?
Yeah, that's T.
Okay. So yeah, I've got 0.682.
And you're using the data from can you share your screen? Let's see, please.
Yeah. Oh, wrong screen.
go. Oh, it's so small. Sorry, I'm trying to. Let's see. Did you paste special or you just Control V?
I copied and pasted.
Okay. 32, 35. The null hypothesis is square. Any reason why? Is that 0?
I think so. Yeah.
Was it there when was it already there or you typed it in?
It was already there.
This is weird because we have almost the same. What's the sum of the column that has the difference? What's your sum there? Column C. Like what's your sum in column C?
Oh, I don't know. Let's see.
Oh, just highlight all of them and it should show it to you on the bottom.
It doesn't.
Oh, yeah.
Oh, yeah, I did that.
Give it a sum and average. Your sum is 1032. Holy cow! Are we using different data set? Which
Maybe. I think so.
which data set did you use? Because it looks like it's the same, but it's just coming up with totally different.
Last back. Let me verify. Group 1, group 2. Yeah, that's the correct data set.
This is weird.
Do you have the same inputs? Are you using the same data?
Yeah, that's what I'm. So I have in column A, my sum is 5766.4. Well, from the top, I got 202.09. 361. I mean, seriously, it's like the same data set. Like 3.69, 182.29.
Average 257.
4, 3, 4. Yeah.
1, 4, 5. And yet you're still getting a different t value.
Yeah, my t value is. Let me share my screen. You see, this is. So let me know if you guys can see my screen.
Yeah.
Yeah.
So this is my first value, and you can compare with yours.
Nope, I can't see your screen.
Oh, let me see. Okay. Can you guys see it? Okay. So like, and this is the one that I use. So this data right here, chapter 12 data A.
Yeah, that's what I'm using.
That's what I use. And copy all this 21 data set in here and paste special here. And then these were automatically calculated. And then I pull 0.9 or 0.90 or 0.9. Let me just do 0.9. And then I put 0 right here. Then not equal to. And not equal to. And then these are just calculated by themselves.
All right, let me reopen that file.
Okay.
All right, now the data set. here. Well, now it's work. Well, that's the point. Okay, now we're matching that I've reset my Excel sheet. I don't know what caused that.
But Bartholomew, you getting the same thing, or we got something different from you?
I'm trying to open up my Excel. This is just messing it up.
Oh, okay.
Yeah.
All right, let's go to number 6. What is the p-value?
Yeah. Also, sorry. P-value here.
0.689.
P-value. Oh, I should probably round this down. Oh, there we go. Come on, come on.
Their significance level. Our significance level is 0.1.
Mm-hmm.
We reject the null hypothesis if the p-value is less than the level of significance. It is higher, so we do not reject.
Yeah, we fail to reject, right?
We fail to reject.
Cool. Suppose your alternative hypothesis instead HAU. Oh, I guess we'll just go in there and change it to greater than.
Yeah. It changes the p-value, so
it brings it down.
it brings it down, but not enough. It's still higher than the level of significance, so we still fail to reject.
Yeah.
We have insufficient, the mean of differences is equal to 0. Yeah.
So option 2. Oh.
Yeah. The option 2. All right, number 9. Now we're on to the next data set, which is the other file.
Oh, okay. I'll probably make a copy of this one. I don't want to.
Yeah, me too.
Move a copy.
All right, which is greater, n or difference or df?
Huh? Oh.
That's
the n should be greater, right? Because df is n minus 1. Let me go back to that to the book real quick. Go to the bulk, and then with this. There's a df. Oh, df equal 26 here. Yeah, I think df is n minus 1.
That makes sense. So then it would be the n is greater.
Mm-hmm.
What is the p-value? Round to 3 decimal places.
Oh shit! I haven't copied and pasted my document data yet, but I'll meet you guys there 1 second.
So where did you get the formula that you copy the values and pasted in it? I'm trying to.
Yes, we took the values from the data set up there, just above question 9, and we copied and pasted that into the paired sample t-test. You know what I'm talking about?
There's
the data set in question 9.
Mm-hmm. Do you already have the new Excel calculation sheet? Because there's a new.
No.
Okay, you might want to download that one. It's let's share my screen real quick. This one.
Yeah, I should be able to post it in the chat.
Oh, you posting there? Okay.
220.
It's this one right here. Can you see my screen, Bartholomew?
Okay.
Yeah.
And and Justin just share it too.
Yes,
Oh, okay.
that's a folder in my Google Drive that has all the Excel sheets
Okay.
to help you. We're on the Unit 2 one.
Okay. Let me.
The one that's labeled Unit 2. So to find out the p-value for question 10, we need to reassign the null hypothesis to equal 0, the confidence level to equal 0.99, and not equal 2. So my answer for the p-value is 0.001.
What? 1 second.
Okay.
Yes. Can you zoom in a little bit? Let me see on because I'm looking at data. Hey, it looks like we have the same thing. I think it's doing that same thing a bit earlier, but
You think so?
oh, did you round up or round down for your p-value? Because our difference is the same, our t-score is the same, but our p-values are coming out way different. Oh, sorry. This is my fault. Instead of not equal to, I put less than. Just ignore what I just said.
Okay, it's got to be not equal to. Now
Yeah,
this match.
well, yeah, it's correct now. So the T is 3.737 and P is 0.001.
Okay, 0.001. Great.
All right, so go back to that quiz. Come back now. P value is
And you should be able to get those files now, Bartholomew.
Yes, I'm trying to open it now. Let me.
and we're failing to reject on number 11, right?
Yeah, we're failing. No, we are rejecting.
Oh, wait, we are?
Yes, we are rejecting the null hypothesis because the p-value is less than the level of significance.
Oh, man, I have to recite this thing in my head several times so I can remember.
I know. It's like double negatives. It's so bruh.
Okay, so we reject the null because the P was significantly lowered.
Yes.
So you decided to try another alternative. Okay, so greater than this time.
P-value increase or decrease. So we gotta change this to greater than.
It looks like it's still the same.
No, it decreased actually.
It did?
Yeah.
Let me see. Less than.
Difference between not equal to, what was our last one?
So now equal to was 0.001 and
now you change it to greater than, and it changes to 0.0006.
could you share your screen again, please? What am I doing wrong here?
I'm sharing my screen.
Okay. Oh, I round mine to the to 3 decimal places. So we're getting the same thing, but already rounding mine to 3 so if you round yours to 3 decimal places.
Yeah, but we don't round in this one, in this question. It's not asking us to do that.
Oh, okay. So
Number 12, right?
let me keep this.
Bartholomew, did you get those files?
Yes, I got it now.
You'll
So
want to download them.
if we don't round, let me see. I will open it. The first one was not equal to, and then I'll click on it and spray it out. How I can see. Okay. Good. So 0.1215 something something something, and then greater than will be all right. Good. Thank you. That helps a lot because I rounded mine. I was messing with me. I shouldn't. I run it or copy and paste.
Yeah, you don't round until the end.
Okay. So
now what? Now 13. Number 12 was decrease. Number 13, what decision do you make? So if the p-value is less than the significance,
we still reject, right?
then we reject. Is the p-value less than the significance point? Yes, it is. So we reject the null hypothesis.
Is that number 14 you just answered?
No, 13. We reject the null hypothesis.
Okay, I already got that.
Now I'm on to the 14. Based on your response from the previous question, what conclusion do you make?
We have
insufficient evidence. We have insufficient.
If we rejected a null hypothesis, then we do have sufficient evidence that.
Yes, we do have sufficient evidence if we rejected. But what's the meaning of our rejection? We have sufficient evidence that there is no mean difference, or there is a mean difference?
There is, because if there's no mean, then we'll fail to reject it. I think. I could be wrong. Let's think through it a little slower. So we fail to reject because the p-value was significantly lower than the mean. No, we reject because the p-value. Okay, this is messing with my brain.
Insufficient. Okay. I believe we have sufficient evidence that there is a mean difference between the two.
Option 3 is what I was thinking.
We have no mean difference between the two groups. No mean difference. Trying to picture what this means in my head.
Oh.
No mean difference, or there is a mean difference. The hypothesis equals zero. So we are rejecting the null hypothesis. So we believe that the mean, that there is a difference in the mean.
Yeah.
So I think that it's 3.
Okay, that's how I was thinking, but.
Because the null hypothesis is saying that there is no mean difference, but we rejected that, so then there must be a mean difference.
Yep.
Okay.
That's
Number
good.
15.
P-value depends on the alternative hypothesis. In general, which alternative would give the smallest p-value? Well, the smallest p-value in this case was not equal to, right?
Well, let's just try it. So not equal to was 0.0012. 0.9 less than was 0.99. It was greater than.
And then greater than. Yeah, so greater than had the least.
Yeah, it should be 4, the greater than 0. Yeah. Determine the 95% confidence interval for the mean difference between the two groups.
So we'll change that to 0.95?
Yeah. 0.95, our null hypothesis.
5.303 and 18.607. Oh wait, point estimate for the. What the heck is a point estimate? All right, I was just reading a confidence interval, so now that they're asking for point estimate, I have to go to the book now.
A point estimate is, I have a definition of that somewhere. So that's just the line over x.
Oh,
What is the point estimate? Okay, first of all, let's go to the paired sample test and look at our confidence level. That's going to be 0.95, right?
which one? Oh yeah, 0.95. Yeah,
And what's our null hypothesis?
0.
And what's our type of test?
Mhm.
Not equal to?
Let me see. Yeah, we usually start with not equal to.
All right. What is the point estimate for this 95% confidence interval? The point estimate. Line over x. Now, line over x is
It's line over D in this
line over x is the sample mean, also known as the sample mean. So I think, if you look at my screen, I think that it's this 11.955 number.
sounds about right.
What is the margin of error for this?
Oh, the margin of error, we can use the formula that we use. One second.
Yeah,
I think I already have in my model.
line over.
Margin of error. Okay. The margin of error for the 95%. So I need a standard deviation first. The number of population. 22. And the standard deviation. So for the standard deviation, I'm using the difference at the bottom, right? The 15.003, because I need a standard deviation to get a margin of error.
Yeah,
Okay, so
I agree.
15.003. All right, come on. All right, so I'm getting 6.269.
Really?
Yeah, so that,
Green.
like, I mean, this one. Yeah. So right here, I put the given standard deviation I put in will be this right here, 15.003, and then the number of population is just 22, which is 22 here at the end, and then my formula is saying, so this K9, because within 2 standard deviation is the 95%, 95 percentile. So that's 1.96. If you go to the applet and put 95%, this is what you get for the standard deviation.
Mm-hmm. And
then it's pretty much saying this standard deviation divided by the square root, this standard deviation times the square root of the given standard deviation divided by the square root of the number of population. This is from chapter 9, chapter 10, it's in chapter 10. That's where we did margin of error. So we can use that formula to just calculate it directly. I built this back when we did that that section.
Mm-hmm.
Yeah, so the two value I used here was this standard deviation, 15.003, and the population number. And let me see if I can go to the book real quick and get that chapter. I think that will be in chapter, let me check 10 first. Margin of error. Oh, there you go. Margin of error. It'll be somewhere here, I promise. Okay. Okay. So imagine M. So M equal 2 times, and the 2 they did right here, they round them. Go to the probability app. I think I already have it here. Probability app. Yes. So you guys can still see my screen, right?
Yeah.
Well, so to get it 95%, you just come here and do 0.95. Oh, that's not what I wanted.
You're going to want to select the middle part.
Yeah. I forgot to do that part. Let's see. Oh, I think I have to select my middle first. So let me do one here. All right. Select my middle. There we go.
Yeah.
0.95. All right. So this is the 1.96 that they rounded. Oh, I freaking hate it when I forget to open another sheet. Let me go back to chapter 10. All right. So margin of error. There we go. So you see they did 2 here, right? So margin of error equal 2 times standard deviation over n. This 2 right here is this that they rounded to the nearest whole number.
Mm-hmm.
And they actually, I think it's there it is. See 1.96. So to get a m equals this right here, the z-score times standard deviation over n. So that's why in my formula here, I did 1.96 because the 95%, that's what you get. If you go to 68 to 90, this is what you would get because that's 1 standard deviation away. And then if you go to 99.7, you get 2 standard deviation away. So it's pretty much saying this times this over the square root of this.
Okay. And so you think the margin of error is 6.26?
Yeah, that's why if we're using the correct if we're using the correct this, which I think is correct because this is variable 1 and variable 2, and this is the difference between them. So I think this is the most correct. So this plus the divided by the normal square root of the normal population will give us that 6.269.
All right. I'll go with that. So what do you have for 18 then?
Let's see, Control V. 18. Input the lower. Oh, it's just this thing right here. 1 second. Let me move my screen away. Oh, I forgot that I stopped sharing my screen.
5.68.
Yeah.
6.
No, 5 points. So if we keep everything the same, it should be 5.303 because they're asking for the lower control, right? What is the lower bound? So it's this right here because they're talking about the confidence interval now. This is the lower bound. This is the upper bound.
All right. So why don't we use, if you look at my screen, why don't we use these two numbers here?
Let's see. Which one? Go to it. Let's see. 5.6.
Right here.
Let's see. What? Oh, so you use the input from over there to get. The only reason why I'm referring to this one is that's why the Apple calculator.
Yeah.
So based on these, and this not equal to, because when you change this, I think that changes to. Are you looking at my screen?
Yeah.
Watch. Okay, it's not changing. Let's see, greater than. Nope, not changing.
It doesn't change.
No, it doesn't change. So I wonder why. We're on not equal to, right?
Right.
Okay. Because yeah, this calculation, let me see what it considers.
I got an idea. You pick one, I'll do the other.
Okay. Okay.
Okay, so
And I'll
I'm
make
going
it
to do the 5.686 and 18.224 for the lower bounds and upper bounds, and you do the 5.303.
Okay.
And then just go ahead and submit, and we'll see what it does.
Well, we didn't do number 4, remember? Are we just leaving it blank for now?
No, I gotta put something there.
Okay. Is Bartholomew still there?
Yeah, he's still here.
Okay. Whoa.
So the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test.
Let me go back to that book. I wonder if they say anything or did they any example remotely close to that.
Yeah.
Probability. Control.
Find the p-value.
Wait a second.
Close. Let's try this. What is line over D again?
Line over D is line over X. So the sample mean.
Okay. Everything.
So I'm using a student's probability app.
Uh-huh.
And I'm going to share screen. So to say the p-value is the area to the left of the t under the curve. This area is so small it is not. Please know that this image was like a probability. The test statistic for 2 means with paired data. This image was.
Okay, so this is what I did. If you look at my screen.
Okay, I'm looking.
Okay, so I removed all the data. And all I did was plug in the values that we have that they gave us. So n, they gave us n, which is 9. They gave us the mean, which I think is line over D. They gave us the standard deviation, which is 3.3. And that allows these other calculations to be done. So it gives us T and DF and p-value. See p-value there.
0.8051. Okay. I mean,
so that's my best guess.
I think it's good enough. At least it did some calculation with That's the best I can think of. I'm going totally blank on that one. So
Yeah, me too.
that's great. So that was 0.08.
Number 4 was let's go past 0.081.
0.081.
Yeah.
All right. 19 out of 19. Giving it a shot. Go to submit. All right. Oh my goodness. Dang it.
What did we miss?
We missed number 15 and number 17. We missed 15 and 17. We got everything else right.
No kidding.
Yeah. So
I
that
think
your
that's pretty dang good.
the formula that you have in number 4, I might need that.
Okay.
So what you did was
Real quick, let's go to 18. What was your answer for that? 5.303?
18, let's see. Yeah, 18 was 5.303.
And 18.607?
Yeah.
Okay.
And then
And then we missed 15 and 17?
yeah, 17 we put 6.269. So that was the marginal error that I calculated. So that was totally wrong.
Man, you screwed up. All right. So margin of error, we don't get that from that. So, all right, let's come up with another guess here. This 95% confidence interval. We need to input the data for line over D again. That's sufficient. Okay. Here's our data. Okay, we got this stuff. 69, right? Yeah. Okay, 95. And we put in,
Let's see.
17, 6.269. So line over D, 1.955. The T is 3.737. The standard deviation is 15.003. There's 22. Okay, I have another thought that the answer is 11.953.
Okay. I'm still on the first one because I can't really submit, so I'll just watch you guys get done before we do the next one. Is Bartolome there? He's awfully quiet there.
He had a lot of background noise, so I muted him.
Oh, okay.
Sorry, Bartholomew. And then we missed 15, so
Oh wait, you got 17 right?
I don't know.
Oh, okay.
I haven't submitted yet. I
Okay.
will change the screen that I am sharing.
1 second. Let me. There we go.
Okay, you see my test, right?
So 11. Wait, 16. 1 second.
I have a strong suspicion I'm going to get 17 wrong.
So let me see. 17.
So we missed 15. As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will get the smallest p-value?
Wait, has I seen which The smallest value. Huh. So it wasn't greater than, I chose greater than, I chose the fourth option.
Yeah, I
And
chose greater than too,
and I was wrong.
Yeah.
So,
I don't get it. That gives us the smaller p-value.
have you tried not equal to? Let's go through them slowly. Let me pull mine up again and see.
I'm thinking p-value depends on the alternative hypothesis and general which alternative hypothesis will give the smallest p-value. I don't know. My best guess is not enough information. Depends on the problem.
That's another option.
I missed one.
No way. Which one did you miss?
I missed the question 17.
17. And what was question number
15.
Uh-huh.
Not enough information.
Not enough. Okay, in 1 second. Let me make
Okay. So we don't know what question 17 is yet. We need to find out the margin of error.
Okay.
And we know that the answer is not 11.953. And what was your answer?
Mine was 1 second. That was question number 15, right? Or 17?
17.
Question 17. Where the devil is that? Oh, okay. Mine was 6.269.
Okay, so we know it's not 11.953 and it's not 6.269. So let's study on our own and we'll come up with another answer and we'll just tell each other when we find it.
Okay. And number 15, what was your answer again?
Not enough information.
Okay.
I can't believe we got everything else right. Like that's amazing. Where did I get that answer? Yeah, I got that. Wow, that was really clever of me.
That was good. I could not have said. I was just gonna keep calculating until something come up right.
I can't believe I got question 4 right. Yeah.
Wait, why did you get to number 4?
0.081.
1 second, let me go back there. Question number 4.
That was the one where I just plugged it in for the differences.
Oh yeah, that's right. That's right. That was good. That was awesome. And that it's just like, because I thought I was there to calculate everything, but it was good that you look at it and saw that they were calculating based on the things that were above there and make the adjustment. That was really nice.
Thank you. I had a theory that maybe they were just giving the differences and that was it. And we didn't need the data because they already did the calculation. And it just happened to be right. So I plugged it in for the differences in our spreadsheet and that was it. So
Sweet.
that was lucky. Should we take a break before we do this next one? You got time for that?
I'm thinking, let's see, 11. I'm supposed to be somewhere a little after 11. But if you guys want to take, like, how long were you guys thinking of a break?
I don't know, like an hour or something. We could also do it tomorrow, I guess.
I'm kind of tight tomorrow. That's like